You are listening to The Vocal Technologist. Spoken tech for your ears.
So a company in Oregon is currently trying to drop millions of dollars worth of AI servers straight into the ocean.
Yeah, and meanwhile, out in Texas, you've got aerospace engineers trying to figure out how to basically beam server power down from orbit.
Right. Welcome to the deep dive, everyone. Today we're looking at the terrifying, incredibly expensive, and really heavy physical reality of the AI boom.
It's a lot heavier than people think.
Exactly. So we've got a really fascinating stack of sources for you today, curated from a bunch of tech newsletters from May of 2026. And, the overarching narrative here is pretty clear. We are officially past the era where AI was just like a clever little box on a browser that wrote poems for you.
Yeah, the paradigm has entirely shifted. I mean, for a long time, the limits of artificial intelligence were strictly software problems.
Right, just code.
Exactly. It was about algorithms, data sorting, optimization. But now, the limits are concrete, they're steel, they're electricity, and just massive, unprecedented amounts of capital.
It's all physical now.
Yeah, the bottleneck is no longer human ingenuity, honestly. It's the physical constraints of planet Earth. The digital world is basically crashing headfirst into the physical one.
Well, let's unpack the sheer scale of that collision, starting with the raw math coming out of Anthropic. Because according to the reporting in our sources, Anthropic's annual revenue run rate, so their projected yearly revenue based on this hyper-accelerated monthly growth, it just passed $30 billion.
Which is just an astronomical figure.
Yeah, and the CEO claims they're on a trajectory that could see them grow by like 80 times this year alone.
Right, which demands a pretty massive reality check. Because to fuel exponential growth like that, better code is useless on its own, You need compute.
Massive amounts of it.
Exactly. Massive, sustained, uninterrupted computational power. And that brings us to the deal Anthropic just struck with SpaceX AI. They secured access to the Colossus One data center down in Memphis, Tennessee.
And the specs on this facility are where that abstract software world suddenly hits a literal brick wall of hardware. The source notes that this single plan requires more than 300 megawatts of power.
That's hard to even conceptualize that.
Right, and it houses over 220,000 NVIDIA GPUs. So Anthropic had to secure access to all of it just to meet their growth demands, which actually allowed them to radically increase their API limits. Basically, opening up the toll road so heavy users aren't capped anymore.
Yeah, and just to put that 300 megawatts into perspective for you, that is enough electricity to power tens of thousands of homes.
Oh, wow.
Yeah, it's essentially the equivalent of a mid-sized city's power draw, just concentrated into a single warehouse that's doing nothing but processing data.
Okay, let's unpack this, because it's like we've invented the ultimate sports car, but we suddenly realize we don't have enough gas stations on planet Earth to actually drive it. And dropping a mid-sized city's worth of power demand into Memphis, well, that brings up a massive secondary crisis.
The electricity gap.
Exactly. America's electricity gap. One of our sources takes a hard look at the U.S. grid, and the portrait it paints is honestly pretty bleak.
Yeah, it is.
The U.S. was already struggling to meet rising electricity demand well before this AI boom really took off. I mean, we've got aging infrastructure, super slow permitting processes for new lines, and shifting consumer habits.
And now you drop multiple 300-megawatt data centers onto that fragile grid, and the equation simply breaks. I mean, it shatters.
It really does.
The source makes a really compelling argument here. The rapid deployment of solar and industrial batteries is no longer just like some long-term environmental goal for the future. It is an existential economic requirement today.
Right, because if you don't have the power...
If you don't have the electricity, you don't have the AI. Power access is the ultimate bottleneck for technological supremacy right now.
Which totally explains the desperate, honestly, borderline science fiction solutions these companies are trying out to bypass the traditional grid entirely.
Oh, excellent.
Like, SpaceX is breaking ground on a massive solar fab in Bastrop, Texas. And they aren't just buying solar panels on the open market. They are vertically integrating the fabrication of aerospace-grade solar cells.
Right, for space.
Yeah. Their goal is to power an orbital cloud network. They actually want to put AI workloads into space.
It's a breathtaking logistical pivot, really. They've looked at the terrestrial grid, realized it just can't handle the load, and decided to literally look up.
And at the same time, other companies are looking out to sea.
Yeah, Panthalassa.
Right, the Oregon-based company I mentioned at the very beginning. So they just raised $140 million. led by Peter Thiel, to build wave-powered AI data centers in the ocean.
Right, and the mechanism there relies on utilizing the kinetic energy of the ocean waves to generate clean power on-site. And then they use the surrounding cold water to directly cool the servers offshore.
Okay, wait, I have to stop and play devil's advocate here for a second. Dropping highly sensitive, multi-million-dollar NVIDIA server racks into the corrosive, violent, saltwater environment of the ocean. That sounds like an absolute maintenance nightmare.
Liz?
Like, how is that actually viable?
Well, that's the multi-million-dollar question, isn't it? The engineering overhead to waterproof and stabilize those systems is immense, but, it just highlights how desperate the search for cheap, unpermitted power and cooling has become.
The cooling alone is a huge issue, right?
Exactly. Cooling 220,000 GPUs running at maximum capacity is a thermal nightmare on land. So the ocean solves the thermal problem and the power generation problem in one swoop. Assuming, of course, you can keep the salt and the hurricanes out of the motherboards.
Right. Big assumption. So if you're attempting to build orbital solar networks and wave-powered oceanic server farms, you need a bank account that looks like a sovereign wealth fund.
Yep. The physical reality of AI is demanding capital on a scale we really haven't seen since the Industrial Revolution.
And that transition, from technological ambition to financial reality brings us to the boardroom tension at OpenAI.
Yeah, the push for an IPO. So Sarah Fryer was brought in to give the company the financial maturity it needs to go public, but her dilemma is essentially this crazy high-wire act.
Because she has to balance these staggering infrastructure costs with proving to Wall Street that the business is actually sustainable.
Right. If she moves too slowly and restricts capital expenditure, OpenAI falls behind Anthropic's 80 times growth trajectory. They just lose the compute race.
But if she moves too fast?
If she moves too fast and burns through billions to build these massive compute clusters, she risks stretching the core business so far that it breaks before the IPO can even happen.
And adding to that pressure cooker is the whole Elon Musk mega trial.
Oh.
Yeah, the newsletters from this stack covered the second week of the trial, focusing heavily on OpenAI President Greg Brockman's testimony. And just to be super clear with you, the listener, we are absolutely not taking any sides in this legal or ideological battle. We are strictly reporting on the claims from the source material.
Yes, exactly. Impartial observers here.
Right, so looking at the documents, Musk's legal strategy is clearly trying to paint OpenAI's executives as being motivated by personal wealth rather than their original nonprofit mission.
Right, and the text messages revealed in court are just a fascinating look at the disintegration of that founding relationship. Like, after Brockman suggested both sides just drop their claims and settle quietly, Musk apparently texted back, threatening that Brockman and Sam Altman would become the, quote, most hated men in America.
Wild stuff. Yeah. But setting aside the courtroom drama for a minute, the underlying theme of that trial, which is the sheer punishing cost of building this technology that is causing another massive shift in the industry.
A shift that affects developers directly.
Exactly. It's the quiet death of open weights.
Yeah, this is a critical ecosystem shift. Historically, open weights meant releasing the actual learned connections, like the heavy mathematical brain of the AI model, so that anyone could just download it and run it privately on their own hardware.
It totally democratized access.
It did, but the sources are warning that this era is rapidly closing up.
So let's pause and look at the mechanism behind that. Why exactly does a high server bill kill open weights?
Well, it's because of the required financial moat. The cost to train these frontier models has just become so astronomically high. We're talking billions of dollars for a single training run.
Right.
So companies can no longer afford to give the underlying weights away for free. If you spend billions on a Memphis data center, your investors demand a return.
So they keep it closed.
Exactly. By keeping the weights closed, companies force users to access the AI through their paid APIs. They essentially become the toll operator. The open source ethos, it just simply cannot survive the reality of modern server farm electricity bills.
And the market is adjusting to these capital requirements in ways that completely break traditional financial gravity. Like, the newsletters threw in a couple of financial wildcards just to illustrate how chaotic things are.
The Y Combinator stat is mind-blowing.
Oh my gosh, yes. Y Combinator's tiny 0.6% stake in OpenAI is now worth over $5 billion. $5 billion for less than 1%.
The returns on being early in this space are just completely defying all historical precedent.
And then there's the whole GameStop situation.
Right.
A company currently valued at around $12 billion is making an unsolicited offer to buy eBay, which is a $56 billion company. And they're doing it using $20 billion in debt from TD Bank.
Which is wild.
Yeah, and while it's not directly an AI story, the source is included because it perfectly captures the madness of the current capital allocation environment. Money is just moving in ways that feel entirely detached from traditional business fundamentals.
Yeah, but while the financial numbers might feel totally abstract and detached from reality, the end goal of all this capital is incredibly concrete.
Right.
The models are getting off the servers and they're walking into the real world.
Quite literally walking. One of the major headlines from the stack is Meta acquiring a startup called Assured Robot Intelligence.
And Wall Street hated that.
Wall Street immediately punished Meta for the spending. Yeah, dropped their stock significantly. Investors are deeply skeptical because they want Meta focused on software and advertising revenue, not bleeding-edge hardware research.
But Meta is completely ignoring them.
Exactly, along with Tesla and a few others.
And they're ignoring that pushback because the global manufacturing stakes are just too high right now. The Bloomberg source on China really lays out the strategy perfectly here.
What are they doing?
So China is using its early lead and humanoid robots to secure absolute dominance in global manufacturing. They aren't just researching these things in a lab anymore. They are actively deploying these humanoid models in tech parks and real factories.
Oh, wow. So it's already happening.
Yeah, and government procurement is heavily subsidizing the rollout. They're basically using their local market as a massive real-world testing ground. The economic estimate right now is that this aggressive deployment will push China's share of global manufacturing to 16.5% by 2030.
Which means the U.S. companies have to stay in the race, or they forfeit the future of physical labor. But I keep coming back to a foundational question here. Why do we need humanoid robots?
It's a fair question.
Like, why go through the absolute nightmare of building a machine with 2 legs, 2 arms, and a head, when a standard bolted-down robotic arm on an assembly line has worked perfectly for decades?
It all comes down to legacy infrastructure. The human world is built exclusively for the human form factor.
Right.
Our factories, our stairs, door handles, tools, they are all designed for a bipedal creature of a very specific height. A robotic arm is incredibly efficient, sure, if the environment around it is perfectly controlled and never, ever changes.
But factories change.
Exactly. A humanoid robot can step into a space built for a person, pick up human tools, and operate within it without requiring the manufacturer to spend millions of dollars redesigning the entire factory floor.
Okay, that makes sense. But the engineering required to actually achieve that is staggering. The humanoid robot actuators source broke down the physics, and it is fascinating.
The kinetic shock data, right?
Every single time a humanoid robot takes a step, it sends a violent kinetic shock up through his leg actuators. The source calculated that a robot walking normally experiences roughly 1 million of these impacts every single month.
1 million impacts.
Yeah. Just think about the wear and tear on the metal, the joints, the motors.
Right. You are essentially trying to apply aerospace-level engineering tolerances to consumer-level mass production. You need materials that are light enough to be agile, but durable enough to withstand 1 million rhythmic, jarring impacts a month without just completely shattering.
But getting AI into the physical world isn't just about heavy industrial manufacturing and, enduring kinetic shock. It's also about interpreting the subtleties of human behavior.
Which is a whole different challenge.
Totally. And that brings us to the familiar. So Colin Angle, the guy who invented the Roomba, has teamed up with former Disney Imagineers to build a robot that is explicitly designed to be snuggled.
It is such a brilliant contrast to the factory robots.
It really is.
So the Familiar is marketed for elderly care, for monitoring loved ones, and just general well-being. It's this emotionally intelligent companion that's trained to read a person's tone of voice, their body language, and basically their overall vibe.
Programming a machine to read a vibe is such a strange concept to me.
It is. Because to interpret a vibe, the AI has to process an incredible amount of messy, nonlinear data, like a slight shift in a person's posture, or a microexpression around the eyes, or a tiny waver in the tone of their voice.
So many subtle cues.
Right. The machine has to synthesize all of those chaotic inputs and somehow output an appropriate emotional response.
Well, if interpreting a human's mood is a chaotic data problem, wait until AI tries to interpret a human's cellular structure.
Oh, biology.
Yeah, this is where AI is tackling what the sources call the fuzzy API of reality. ByteDance, the company behind TikTok's algorithm, they have a new venture called New Labs, and they just presented an AI-designed therapy at an immunology conference that targets a protein-protein interaction that was previously thought to be completely undruggable.
And to understand why this is such a monumental engineering shift, we really have to contrast how AI handles human biology versus how it handles computer software.
Right, and the sources provide a brilliant breakdown of this difference. Because on the software side, AI is proving to be unbelievably effective.
Extremely effective.
The sources highlight Salvatore Sanfilippo, who used AI to write a highly complex array data type for Redis in just 4 months. The AI helped him venture into levels of architectural complexity he normally would have totally avoided.
It mapped out structures, caught bugs, all of it.
Yeah. Or look at Stripe. They used a tool called RubyFMT to format 42 million lines of Ruby code. But the key takeaway from the source is that this works so well because code has clean rules.
Exactly. Code operates on a clean API, an application programming interface. It has definitive, rigid rules. If you write bad code, the compiler throws an error.
It just fails.
It fails immediately. Writing code is kind of like playing chess. If you make an illegal move, the board literally stops you. The feedback loop is instant, it's logical, and it's definitive.
But human biology does not have a clean API.
Not even close.
Biology is incredibly fuzzy. Designing a drug for a human body is like playing chess on a moving boat during a hurricane, where moving your knight somehow makes your opponent's bishop catch on fire.
That is a perfect analogy.
The feedback loops are completely chaotic. You can design a molecular structure that looks absolutely perfect in a computer simulation, but when you put it into a living organism, a million different variables interact.
Right. When a biological model breaks, you can't just run a debugger to find the exact line of code that went wrong. The output is fuzzy. There are compounding caveats at every single step of the process.
And this fuzziness is where the current limits of AI become glaringly apparent. It connects directly back to what the sources call the senior engineer problem.
Yes, the agent skill source highlights this beautifully. AI coding agents are highly capable of generating massive amounts of output, sure, but they completely lack instinct.
Right, no gut feeling.
Exactly. They don't have that gut feeling that a human develops after years of dealing with messy reality.
And AI basically acts like a brilliant junior developer. It will do exactly what you tell it to do at blinding speed, even if the underlying idea is structurally terrible.
Yeah.
It just happily skips the senior engineer work, the deep architectural planning, the defensive coding, the anticipation of bizarre, real-world edge cases.
Unless, of course, that discipline is explicitly hard-coded into its instructions.
Right. Which brings us to the concept of specs maxing.
Such a 2026 term.
It's very 2026. But the mechanism behind it is so crucial. The real act of software engineering is no longer typing out the actual code. The job is now writing hyper-detailed, rigorous specifications.
The guardrails.
Exactly, the guardrails. A human has to build an airtight conceptual box around the AI so it doesn't just confidently run off a cliff. Whether you are designing molecules for an undruggable disease or structuring 42 million lines of code, the AI still desperately needs human-defined guardrails. It needs our instinct for the fuzzy, unpredictable nature of reality.
Because we are forcing these models out of the pristine, strictly logical world of software and pushing them into the chaotic physical and biological world, and that transition is proving to be incredibly difficult.
So what does this all mean for you listening to this deep dive? It means we are witnessing the deeply messy, wildly expensive, and physically demanding teenage years of AI.
That's a great way to put it.
It is no longer just a weightless parlor trick living in your browser.
Yeah.
It is demanding all of our electricity, billions of dollars of our capital, and massive, grueling advancements in our hardware, just so it can learn to walk on 2 legs, interpret our body language, and cure our diseases. It's out of the box. And its hunger for physical resources is insatiable.
And that hunger is really the defining trait of this era, which brings up a final provocative thought from the source material that I think is absolutely worth dwelling on.
Oh, the brain optimization part.
Yes.
Yeah.
Amidst all this reporting on 300-megawatt data centers, orbital solar arrays, and wave-powered oceanic facilities, there was this small, profound note about the human brain.
It's an incredible juxtaposition.
It really is. The source pointed out that the human brain optimizes for bits per ATP, and ATP is the core energy currency of biological cells. Because consuming energy in the wild was traditionally so difficult and dangerous for our ancestors, the human brain evolved to maximize information retrieval and complex computing using the absolute least amount of energy physically possible. We run our immense cognitive capabilities, our ability to write software, engineer rockets, and feel complex emotions on roughly 20 watts of power.
20 watts. That's literally the power draw of a dim light bulb.
Exactly. So here is the question for you to ponder as we wrap up today. We are currently terraforming our energy grid, pouring billions into massive data centers, and launching wave-powered oceanic facilities just to feed our artificial brains. Will our machines ever achieve the biological elegance and incredible thermodynamic efficiency of the human mind? Or are we destined to forever burn through the Earth's physical resources just to keep our AI thinking?
Man, that is a heavy question, and it really puts that 300-megawatt facility in Memphis into stark perspective. Are we building the physical future, or are we just building the most resource-inefficient brain in history?
Something to think about.
Definitely. Well, thank you so much for joining us on this deep dive. We've loved unpacking this stack of sources with you, and we promise we'll have even more fascinating insights ready for you in the next one.
Spoken Tech for your ears.